Hello, dear student. Welcome to GDC and welcome to GDC English YouTube channel. So, dear student, in the continuation of the Pharma Thunderstorm series, today I'm 𝘂𝙀𝙎𝙎 here with the next topic, that is acid, base, and buffer. So, dear student, in this part we will discuss about some basic concept like what is acid, what are the we can say principle of acid, concept of the acid, application of the acid in the pharmacy, conjugate acid and base, buffer, types of buffer, and we will do the MCQ relevant to this topic. So first we will start with the theory part, that is what is acid and base. What is acid basically, student? So acid, I hope you know very well acid. Like if anyone acid is like acid, I had taken the name and in your mind, okay, acid means HCl, that is in the stomach, having the pH from the 1.5 to 3.5 range. Okay, base, okay, we are having the intestinal juice, that is having the basic pH. Okay, so what is acid? An acid is a substance that is that is capable of donating a proton, or we can say your hydrogen ion, that is H positive ion, to another substance. Whereas what is your base? Base, a base is also a substance or ion that is able to donate what? Hydrogen ion. Able to accept a hydrogen ion from an acid. Regarding the example of base, we are having the NaOH, KOH, we are having the MgOH whole twice. And example of acid, like I hope you are very familiar about the hydrochloric acid, sulfuric acid, nitric acid. And the pH of the acid are below 7, whereas pH of the base are above 7. They are sour in taste. Acid are sour in taste, whereas base are bitter in taste. B means base, B means bitter. So base are bitter in taste, having the pH value greater than 7. Acid are sour in taste, having the pH value less than 7. Next, we are having the few theories and few concepts that is going to tell you that how we can explain an acid. We are having the basic 3 theories. There are other theories also, but majorly these theories have been used till now. So first and most important, we are having the Arrhenius theory. So according to Arrhenius, an acid is a substance that can release the H positive ion. When we dissolve it into the water. So acid is a substance that releases the H positive ions when we dissolve it into the water. Suppose we are having the HCl plus H2O, that is going to release H positive and Cl negative. Got it? So next definition about the base. Base is a substance that can release the OH negative ion. OH negative ion. Suppose we are having the NaOH, you are able to see the example here. If we are having the KOH, that is also undergoing the K positive, OH negative. MgOH whole twice, that is Mg2 positive and OH negative. That is your base. So base in substance that is releasing the OH ion concentration, OH negative ion, according to the Arrhenius. Student, don't confuse there regarding the acid and base. Acid are the substance that can release the H positive ion when we are going to dissolve into the water, whereas base is the substance that is undergoing the dissolution. When base is undergoing the dissolution, it releases the OH negative ion into the solution. Our next theory that we had used, that is Lowry-Bronsted theory, or we can say Bronsted-Lowry theory. This theory basically related to the proton only. So you have to know, like, Bronsted theory is basically for the proton, and it is for the non-aqueous solution. It is basically relevant to the non-aqueous solution. We are having the titration, like we are precipitation titration, complexometry titration, diazotization titration, gravimetry titration, and non-aqueous titration. So in non-aqueous titration, the acid-base concept that we had taken as a reference, that was taken as a standard, that is Bronsted-Lowry concept. So what exactly the acid according to the Bronsted? So according to the Bronsted, acid is a substance that can donate the proton, like H positive, NH4 positive, BF3. These are the proton that is donated by the acid. And base are the substance which accept the proton. Base is the substance which accept the proton, means OH negative and NH3 positive. So base is the substance which accept the proton, whereas acid are the substance which can donate the proton. So you can use the trick that ADP, like adenosine diphosphate, no, it is your acid are the substance that can donate the proton in case of Bronsted-Lowry concept. Regarding the base, you can use the trick BAP. Got it? Like base are the substance that can accept the proton. Got it? Next theory we are having the Lewis theory. Lewis theory basically relevant to your electron, lone pair of electron. Bronsted theory, in which we you have to remember the trick, that is ADP, means acid are the substance that can donate the proton. Next, we are having the Lewis theory. Lewis theory is basically what? Lewis theory is according to Lewis theory, acid is the molecules or ions that can accept the lone pair of electron. Accept the lone pair of electron are your acid, and that is H positive, NH4 positive, Na positive, and copper 2 positive. These are the acid that in or we can say ion and molecules that can accept the electron. Means acid can accept the lone pair of electron. 𝚿𝐴LE, acid are the acid can accept the lone pair of electron according to the Lewis theory, whereas base are the substance that can donate the lone pair of electron, BDLE. Base are the substance that can donate the lone pair of electron, and we are having the example OH negative, chlorine negative, and CN negative. Got it? So these are the basic three theories that we have to use to classify the acid base and acid base. Like first we are having the Arrhenius theory, secondly we are having the Bronsted-Lowry theory, third, and next one we are having the Lewis theory. And now we will discuss about the applications of the acid base and buffer. Dear student, on the daily basis from early in the morning till the late night, you are having many of the things in your surrounding. Many of the things is bitter, many of the things are sure. So like if someone like if your parents, your brother, your elder brothers, and maybe younger brother has told you that sister and brother, you have to read today, you have to do hard work, smart work, that is going to be better for you, that is going to be that act as an his or her voice act as a base for you. Means they are just saying it is good for your it is good for your future also, as well as your present also, that you should have to focus on your study. But their lines and their words act as base for you, act as bitter for you. So don't take the word line of your guardians, your geriatric parents, and your elder brother, younger brother, and sister. Don't take it as a bitter or evil line. No, they are just thinking about you. They are having some emotions for with you. They are having some care for you. So respect them, respect their words, respect their lines. and try to be include their each and every good thought line and their discipline in your life also, because we have to learn from our ancestor, we have to learn from our senior faculty. Got it? So every day make a habit, like from early in the morning till night, you always having a learning attitude. It is not like that one time you are just thinking, second thing, no, you are just skipping all these things. Be always be in this learning phase. Always your graph of learning is like that. It is not like that. No, this graph is not tolerated. This sigmoid graph is also not tolerated. It is not like that. You are just speeding your studies, and then at the time of the examination, uh, you just follow the steady state, like just like an steady state plasma concentration after 4 to 5 half life. No? It is not like after 4 to 5 hours you just have to be saturate. No, that is that is inside the body, but we have a linear state, and we can say progressive curve for our study and the time. Always in the mindset, always you are having the mindset that now that is the right time to study hard, that is the right time to do best for your future also, student. You can learn from each and everything, student, each and everything. Suppose you are using like sunglasses, you are using your these type of glasses. So try to search what is the power that you are that which powerful contact lenses you are using. What are the if like you are having the hypermetropia, myopia. If you are able to see any of the strip of any of the medicine, if your brother, sister, mother, father, grandfather, grandmother, any of the member in your family are taking any of the medicines, try to research, not research, try to do the research. Like, okay, my father if I personally don't want any of your parents and non have to take any of the medicines, okay, skip the medicine part. If they are using some herbal things, like they are using clove, fennel, ginger, they are using soap, they are using cinnamon, they are using cardamom. Try to search their family, their biological source, their chemical constituent, their use also. Got it? Like someone is taking the benzoin. What is benzoin? What is the nutmeg? So try to search on these things, student. Always, as a student of GDC and me, you are having a positive mindset for your study. Got it? So next you are having the application of the acid base and acid and base. So in our journal pharmacy, acid and base are being used as an acidifying agent. This is very simple. As an acidifying agent, base is also used in the making of the soap. Base is used in making of soap, paper, and synthetic fiber. Base act as an antacid, means they can neutralize the acid. We can use base in the water purification. Acid we can use as a reagent in laboratory, and we can use solvent in the industry. Got it? Like HCl in the stomach is act as an, you know, uh, uh, acid in the stomach, that is the hydrochloric acid, act as an killing agent for the microbes that has entered via the food. Got it? Next we are having the buffer. Next we are having the buffer. What exactly the buffer? Buffer are compound or mixture of compound which resist the change in the pH upon addition of the small amount. Student, please focus here only. It is not like that you are just listening me and your mind is anywhere other, and you are just you are just we can say enjoying the evening and in evening snacks, and you're just doing the dinner. No, be focused here only. Always when you are going to read any of the topic, you have to be there only in the topic. Got it? So buffer are the substance that is or compound or mixture of compound which resist, means it is not going to change when small amount of acid and base. Same you are having, you also are having the buffer, means sometime like if the family responsibility is there, if the health issues is there, any other environmental condition are unfavorable for your study. So in that all unfavorable and sudden we can say change in the life, as we are the human being, we are having the many responsibilities and the duties. So you always having a buffer for your studies. It is not like that one day you are having so much responsibilities, maybe the health issues, maybe the environmental condition is unfavorable for you. Having buffer means if 2 to 3 days you had without the study, then it doesn't impact on your steady state. It doesn't impact on your progressive graph. Got it? So example of buffer, we are having the soda ash, that is the sodium carbonate buffer and boric acid buffer. And next we are having the two type of buffer. We are having the types of buffer include acidic buffer. So an acidic buffer is a combination of what? It's a combination of weak acid and its salt with strong base. Weak acid and its salt with strong base, that is weak acid and salt with strong base, or we can say conjugate base. Weak acid, suppose that is acetic acid and it's salt with the strong base. Salt with the strong base, how it is formed, sir? Student, please be focus here only. The buffer concept is very important, and many of the students are having doubt in this concept. So I had told you acid buffer are the buffer that is made by the combination of your weak acid with its salt with the strong base. So how it is formed? It is formed from what? It is formed from what? With its salt. Its salt means weak acid salt. It's salt with strong base. Okay. So its salt means acetic acid plus NaOH, that is going to react to form this. And it is CH3COONA, and there is a release of the H2O. H2O is released here. H2O is released here. So that is formed, the salt of its strong base is formed, and it is combined with the weak acid, and it is we can say act as an example or act as an acidic buffer. Same is in this format, sodium carbonate, hydrogen carbonate and the sodium carbonate. These are even like phosphoric acid and sodium carbonate. These are the these are also act as an acidic buffer. These are also act as acidic buffer. Next, after we are having the basic buffer. Please be focused here only, student. Basic buffer, same as having the definition as that of acidic buffer. These are base, or we can say weak base with its salt with the, these are the weak base with its salt with the with strong base. So base and its salt with the strong acid, that is weak base and salt with the strong acid. It's salt with the strong acid. Okay, that is ammonium hydroxide. Okay, ammonium hydroxide, that is your weak base, and its salt with strong acid means NH4OH, strong acid. Strong acid means HCl. So they are undergoing the reaction, means weak base as well as weak base as and strong acid undergoing the reaction, and there is a formation of the NH4Cl and release of the H2. This is release, and this is act as an salt of strong acid. Salt of strong acid. Same continuation, we are having the ammonium hydroxide. Ammonium hydroxide, and this is the same ammonium hydroxide and the ammonium carbonate also. Got it? So this is about the concept of the buffer and types of buffer. First we are having the acidic buffer, then basic buffer. Next we are having the buffer capacity. What is buffer capacity? Sorry, buffer action. What is buffer action? So it is defined as the ability of the buffer solution to resist the change in pH value on dilution or on the addition of small amounts of acid and base. So it is the ability. Got it? What is buffer action? It is the ability. In the exam, the question is like that: buffer ability is the buffer action is the ability or strength. It is the ability of the buffer solution that resists the change in the pH value on addition of very small amount of acid and base. Small amount of acid and base. Got it? So here is a representation via a we can say equation. pH is equal to log of A negative divided by HA is equal to pKa plus log conjugate acid or we can say conjugate base divide acid. So pH is equal to log A, HA is equal to pKa plus log of conjugate base by acid. That is your buffer action. Next, what is the buffer capacity? What is buffer capacity? Sir, buffer capacity basically we can define as it is defined as the mole of an acid or base that required to change the pH of a ⅓ buffer solution by 1 unit. So it is defined as the mole of an acid or base that is required to change the pH of 1 liter of buffer by 1 unit. 1 liter buffer solution by 1 unit. So for there must be few properties to be a good buffer, like higher buffer capacity, more effective control on change in pH. It is a unitless number. It is not having any unit now. Also we can say buffer capacity is your buffer Efficiency. Efficiency, that is another name of buffer capacity. Buffer index and your buffer value. These are your buffer capacity. Buffer efficiency, buffer capacity, buffer index, and buffer value. All these statements are similar. Got it? Next concept we are having. Conjugate acid and conjugate base. Conjugate acid and our conjugate base. Suppose we are having the Bl acid. Bl acid means Bronsted-Lowry acid, and we are having the Bl base means Bronsted-Lowry base. And here is the conjugate base plus conjugate acid. So acid is undergoing the formation with the conjugate base, and base undergoing the formation with the acid. So these are the CP, conjugate pair, and same our Bronsted base as well as conjugate acid act as an conjugate pair. Got it? About the few detailed explanation about the CA and CB. CA, that is not chart test accountant, it is conjugate acid and it is conjugate base. Conjugate acid is the substance which can be formed by the loss of proton. Conjugate acid is the substance which can be formed by the loss of the proton, whereas conjugate base is the substance which can be formed by the gain of proton, which can be formed by the gain of the proton. Got it? Suppose we are having the acid and conjugate base. Acid, suppose we are having the dihydrogen fluoride, and base, conjugate base, we are having the HF. Same is in this case, base and our conjugate acid. Suppose we are having the ammonia as an base, and ammonia is positive ion, that is act as an conjugate acid. Same is in the same again we are having the OH plus H2O, that is our conjugate acid. This case your hydrogen ion and your water. Got it? Next we are having the hydrogen ion concentration and the pH chains. Hydrogen ion concentration and the pH chains. So first you have to know what is pH. pH is the negative logarithm. Most important, student, this question was asked previously many of the time. the negative logarithm to the base 10 of hydrogen ion concentration is called pH of the solution. Whereas pOH is what? pOH is what? The negative logarithm of the base 10 of OH negative ion concentration. That is your pOH. How we can represent, sir? We can represent pH in this format, or we can say above said statement we can write in simple format like this. And regarding the pOH, pOH is your negative log 10 of OH negative ion concentration. OH negative ion concentration. Got it? I hope this is clear to everyone now. Next, we are having the pH scale. pH scale. Basically, pH scale we can use to measure the acidity and basicity of a substance in its aqueous solution. I hope you had seen the pH paper in your semester practicals. That is showing the green color at the 7 and red color at 0 and around dark color like at 14. So 0 to 14 we are having the pH scale. Highest acidic means toward the 0, highest basic means toward the 14. Got it? So pH scale is based on the pH value, that is negative logarithm of base 10 of H positive ion concentration. It is not base, it is not like bitter, na? It is base 10. Base 10. Got it? Base 10 means somehow a mathematical term. It is not chemistry term like base. No. It is a mathematical term. Got it? So now we will do some questions, some new concept relevant to today's series. First, like the pH of a pharmaceutical buffer system is calculated by. Here is the pH partition theory, Michael-Menten equation, Henderson-Hasselbalch equation, 𝘂𝙎𝙎 equation. pH partition theory just basically we can use in case of distribution. Michaelis-Menten equation, that is enzyme relevant. 𝘂𝙎𝙎 equation, that is dissolution relevant. And Henderson-Hasselbalch equation, most important. Many of the time in your GPAT, NIPER, Pharmacist, Drug Inspector, many of the time. Very, very important. Second question we are having. A strong acid has a strong acid has a weak conjugate base. Also very important. So strong acid has a weak conjugate base. Strong acid has a weak conjugate base. Next question for you. According to the Bronsted-Lowry theory, Bronsted-Lowry theory, as I told you in the explanation, that is basically relevant to the we can say proton. So according to the Bronsted-Lowry theory, acid are the substance that can donate the proton. ADP, you can use the trick for the acid in the Bronsted concept, and for the base you can use base are the acceptor of the proton. Got it? Next question. Which of the following is a conjugate acid and base pair? Which of the following act as a conjugate acid and base pair? So your SCN and your cyanide ion, that is act as an conjugate acid and base pair. Like this is your weak acid, this is your strong base, strong acid, strong base, your strong base, base and your weak acid. So this is your conjugate acid and this is your conjugate acid and base pair. Next question, an important question, you have to remember this. Muriatic acid is the synonym of what? Muriatic acid, that is also known as your HCl, that is formed in the human body as well as in many of the synthetic reactions. So we can use it act as an reagent in the laboratory, in the industry purpose we can use. So muriatic acid is your hydrochloric acid. Hydrochloric acid is also known as muriatic acid. So dear student, this is relevant. This is all about the acid, base and buffer. I hope you had enjoyed this session. Please like this video, follow our YouTube channel, subscribe the channel, write your doubt in the comment box. In the next part, we will discuss about the next concept of the inorganic chemistry. Up to that, keep watching. Have a good day. All the best for exam.